Hello friends, this is a quick video I'm going to make on the concept of reflection and refraction. So these are the two topics I'm going to cover in our today's lecture video. Now, first of all, reflection. Reflection happens in the case of mirrors. So let's say if this is a surface and this is a mirror and the light falls on the surface of the mirror and this is falling at an angle of, let's say, angle theta, and this theta is also called as incident angle. So if falls on the angle theta, it's gonna get reflected also at the same amount of angle theta. So angle of incidence is equal to angle of reflection. So this is angle of reflection. So this is also called law of reflection. So law of reflection says that angle of incidence is equal to angle of reflection. Now, based on this one, we can figure out how the images are formed in the mirrors. So right now I'm going to talk about the curved mirrors. Curved mirrors. So in curved mirrors, I'm going to talk about two different types of mirrors. The first one will be concave mirror. So if I'm seeing, this is a curved mirror. First of all, if I'm seeing this mirror from this side, this is called concave mirror. Concave mirror. And if I see the same mirror from this side, this will become convex mirror. Convex mirror. Now we're going to try and see how the images are formed in case of concave mirror and in case of convex mirror. So first of all, I'm going to start with the concave mirror. So I'm going to change the color of my pencil. Now let's say this is a mirror, concave mirror given to me. And before jumping into how the image is formed, we're going to talk about some of the terminologies. So if I complete, this is a curve, and if I complete this curve, this kind of becomes a complete circle. If I draw it properly, it's gonna look like a circle, and circle always has a center. So that center, this center is this, whatever the center of this circle is, that center is same for this curved mirror too, isn't it? So this curved mirror, so they both share the same center. So this point, which is the center of the circle, that point is also called center of curvature for this mirror. Center of curvature. Now this point is called vertex point. Vertex point. What is vertex point? Where the mirror cuts the axis. Which axis? This axis. X-axis. X-axis. And the midway point between the vertex and the center of curvature is called focal point. Okay, and then let's say if I'm placing the object here on the right hand side, we will take two rays and try to figure out how the image is formed, and those two rays will start from the tip of the object. So first ray will be parallel to the axis. So this is the axis. First ray will be parallel to this axis and will pass through the focal point. So this is how it's going to move in this direction and will pass through the focal point in this direction. And the second ray again will start from the tip of the object and will pass through the center of curvature. and where these two rays will meet, I will draw the image at that point. So these two rays are meeting at this particular point. So this is where the image will be formed in this case. Now, this image, let's look into the traits of this image. This image is smaller than the real object. So this was, if I assume this was an object, then image is clearly smaller than the object. So one of the trait of the image is it is smaller in size. Smaller in size. Another trait of the image is it is inverted, upside down, you can say, upside down. Upside down images are also called as real images. Real image. If the image would have been formed on this side upright, then that image would have been called a virtual image. Whenever the image is formed on the downside or in the opposite direction to where the object is, opposite to the where the object is, then that's called a real image. Now, this was a case when the object was placed away from the center of curvature. So I'm going to call it as case 1. Case 1, object was placed away from center of curvature. Now, we're going to talk about the second case. Second case will be when the object is placed between focal point, let's say this is focal point, and the center of curvature. So I'm going to place the object here. What kind of an image will be formed in that scenario? So again, rules going to remain the same. First ray parallel to the axis, will pass through the focal point. Second ray again from the tip and will pass through the center of curvature. Now where these two rays will meet, I will draw the image at that point. So I will draw the image down here. So this is the image, and I can clearly see this image is bigger in size. So traits will be bigger in size, and the second trait gonna be it is real image because this is upside down, so that's why it is called a real image. So this was the case when the object was placed between center of curvature and focal point. Now I'm going to talk about the third case. Third case is when the object is placed on the center of curvature, or let's say on the focal point. That'll be the better case, focal point, and this is center of curvature. So this is where the object is placed. So if the object is placed here, again rules gonna remain the same. So first ray parallel to the axis passing through the focal point. Second ray again starting from the tip passing through the center of curvature, something like this. Oops, I drawn it wrongly, a little wrong. So it should be something like this. So because I haven't drawn them up to the scale, once you're going to draw them up to the scale, you will find these two rays will be parallel to each other. They will never intersect each other. So when the object is placed on the focal point, no image is formed. No image is formed. So I'll encourage you to draw this by using the correct measurements, and you'll find that these two rays will never intersect each other when the object is placed on the focal point. Now, the fourth case which we're going to talk about is when the object is placed between the focal point and the vertex. This is focal point and this is the vertex. This is where the object is placed. What kind of an image is formed in that scenario? So again, let's see what kind of an image is formed. So first ray parallel to the axis passing through the focal point. Second ray again starting from the tip and will pass through the center of curvature. Now I can clearly see these two rays are moving away from each other. The gap in between these two rays is increasing. But here on the other side, the gap is decreasing. So I'm going to extend these rays on the other side of the mirror. And here, if I keep on extending these two rays, this ray and the other ray, I'll find that they will meet on the other side of the mirror. So here I'm going to draw the image. So what kind of image is this? This is a virtual image because this is upright, and this is bigger in size also. Bigger in size. So this is a case when the object is placed between vertex and the focal point on a concave mirror. So all these four cases were for the concave mirror. Now we're going to talk about when the object is placed on the center of curvature. So this is focal point and this is center of curvature. If the object is placed on the center of curvature, then first ray again parallel to the axis passing through the focal point. Second ray, it will be a little tricky to draw, so starting from the tip has to pass through here, so straight down. That's how you're going to draw it. And where these two rays, at that point you will draw the image. In this case, you're going to get a equal size but a real image. So these were the different cases when the object is placed at different locations in a curved mirror that is concave. Now we're going to talk about a convex mirror. Convex mirror. And this mirror is also called diverging mirror. Diverging mirror. Concave mirror is called converging. So this is converging mirror. Now let's see what kind of image is formed in the diverging mirror. So in case of a diverging mirror, you can place the object anywhere. You can place it here, you can place it here, you can place it here. You will always get one result. That is, image will always be smaller and virtual. The perfect example of the convex mirror will be when you see I mean in the stores to avoid the stealing, or you can see these kind of mirrors in the parking lot. So let's say I'm going to place the object somewhere here, neither too close, neither too far away. Now I cannot show the focal point on this side. Focal point will always be on this side, and the center of curvature will always be on this side. Now, first ray parallel to the axis, same story, passing through the focal point. Okay, because ideally what's going to happen is this ray will strike this surface and gonna move in this direction. But on the other side, we're going to pass it through the focal point. That's how we're going to show it. And the second ray has to pass through the center of curvature. So second ray will pass through the center of curvature. Where these two rays will meet, I'll draw the image at that point. So this is where these two rays are meeting. So this is the image. it is smaller in size, smaller in size, and virtual. So that's how you're going to draw the images in case of mirrors. Now, in this one, as I told you earlier, whenever we are talking about convex mirror, irrespective of wherever you place the object, you place it here, closer to the object, away from the mirror, wherever you're going to place it, one kind of an image is formed, smaller and virtual. So hopefully you were able to understand how the images are formed in the mirrors. Now we're going to talk about the lens, how the images are formed in case of lens. Now, before I jump into the images, how images are formed in case of lens, we're going to talk about law of refraction. Refraction. So law of refraction says that when a ray passes through a surface or from a rarer medium to the denser. So for example, if this is air and this is water, so when a ray of light passes from the rarer medium into the denser medium, it will always bend towards the normal line. Now you're going to say, what is the normal line? So this orange line which I'm drawing, this is normal line. So if let's say this is the angle of incidence, angle is always taken with respect to the normal line. You cannot take it with respect to the horizontal line. This will be wrong angle. So if this is the incident angle, this is the angle of refraction in this case. So the line, law of refraction says when the light passes from rarer to the denser medium, then it will bend towards the normal line. And that's what's happening in this diagram. This would have been the ideal path. This would have been the path of the light, but it bent towards the normal line, which is the orange line. So that is law of refraction. And if the light passes from the denser to the rarer, so for example, from the water into the air, then it will bend away from the normal line. So if this is angle of incidence, this will be the angle of refraction. So again, I can see ideally it would have followed this path, but rather than following this path, it has bent away from the normal. So this is the law of refraction. Based on this concept, we're going to see what kind of images are formed in case of lens. So in lens, we have two types of lens. One is converging lens, another is diverging lens. So the first one which I've drawn, this one is converging lens, converging lens, converging lens, and this one is diverging lens. So let's start with the converging lens first of all. And just want to tell you, converging lens is also called as convex lens. Converging is convex in this case, and diverging is concave. So this is the lens. This is the vertex or a center of the lens. And this is the focal point on this side, because if I extend this circle here, there will be a circle like this, and then so there will be a center and focal point. That's how I'm drawing it. If I extend this also, this curve, this one, this will form a circle also. So hopefully you were able to understand that why I'm drawing the focal point and the center of curvature. So this is focal point, this is the other one is the center of curvature. Center of curvature. And on the other side also there will be a focal point, and then the center of curvature too on the other side too. And now I'm going to place the object somewhere away from the center of curvature here. Center of curvature sometimes is also called twice of focal length, 2f. So here you can draw it 2f too. Now in this case also we're going to follow the similar kind of a rule. First ray parallel to the axis, once it's going to pass through the vertex or the center of the lens, it will pass through the focal point on the other side this time around, because it's a lens, so the ray can pass through the lens. And the second ray in this case will pass through the vertex, not the center of curvature. I'm telling you, this is where students make a mistake. They start passing it through the center of curvature and they get the wrong answer. So this is a heads up, please remember this. The second ray will pass through the vertex. So second ray, let me see if I can use the ruler and draw it. And this is how the second ray will look like. So where these two rays will meet, I'll draw the image at that point. So somewhere here the image will be formed. And this image will always be smaller in size, and real image formation. Again, here I missed the vertex, but always pass it through the vertex point. Now, this was the first case when the object was placed away from the center of curvature or away from the 2f. Second case we're going to talk about when the object is placed between f and 2f. So again, I'm going to draw the axis, and here I'm going to try and draw the lens. Let me see if I can draw some better shapes. Oops, yeah, that looks neat. And approximately. And then here I'm going to say this is f, and this is I'm going to call as 2f. This is where I'm going to call it as f. Here I'm going to call it as 2f. And the object is placed between 2f and f. That's where I'm going to place the object. And first ray, again parallel to the axis, will pass through the focal point. Second ray will pass through the vertex of the lens. And where these two rays will meet, I'll draw the image at that point. So you can see these two rays gonna meet way away from the focal point. So I have to keep extending the line. So somewhere here, so it goes way away. Hopefully you were able to understand. So I have to keep on extending. This is gonna be huge. So it's gonna be somewhere like this. And if I have to extend this line, and I will draw the image somewhere here. This is where the image will be formed. And I can clearly see this is a real image, and bigger in size. And so this was the case number 2. Case number 3, when the object is placed on the focal point. So again, in this case, if you're going to place the object on the focal point, there will be no image. I'll leave it for you guys to do it, but this is again really important case to try and practice this one. The ray is going to come out to be parallel. So I'll give you a hint. It's going to look something like this. So this is F, and the object is placed on the focal point. So first ray parallel to the axis will pass through the focal point. It's going to go like this. Second ray will pass through here, and these two rays will come out to be parallel. So no image will be formed. So try and do this one. Again, this is important from the exam point of view. And now I'm going to jump on to the next case when the object is placed between the focal point and the vertex. So again, I'm gonna take the ruler and try and draw some shapes, and this is the axis, and now I'm gonna try and draw the lens. So this is how my lens gonna look like, and this I'm gonna call it as, here I'll call it as focal point, and here other focal point, and the object we will place it between focal point and the vertex. So this is where I'm going to place the object, and let's see what kind of an image is formed. First ray parallel to the axis passing through the focal point. Second ray will pass from the vertex. Second ray is going to pass through the vertex. Oops. So I can clearly see in these two rays that their gap is increasing on the right hand side of the image. So this is how the first one was. So here the gap keeps on increasing. So these two rays will never meet each other. But if the gap is increasing on this side, on the other side the gap will reduce. That means, so this is this ray. If I extend it on the other side, so this dotted line is the extension on the other side. So where these two rays will meet, I'll draw the image at that point. So now you might have guessed it by now what kind of an image is formed. So this is a virtual image and bigger in size. Virtual and bigger in size. Bigger in size. All right, so these were the different cases for the convex lens or a converging lens. Now we're going to talk about the diverging lens. So the diverging lens is something like this, and in this diverging lens there is only one case. Wherever you're going to place the object, it will always be virtual and smaller in size. Virtual and smaller in size. So this is the focal point. This is I'm going to call it as center of curvature, or 2f. Here focal point 2f. Now first ray parallel to the axis, first ray, I'm going to place the object here parallel to the axis. I'm going to pass through the focal point like this. So this ray is bending. A second. There is a technical difficulty. 1 second, guys. Oops, thank you. So first ray, as I said, it is passing through the focal point because it is bending, so it's gonna go like this. And the second ray will pass through the vertex. Where these two rays will meet, I'll draw the image at that point. So this is where these two objects are meeting. I'm going to draw the image here. So I can clearly see this is smaller in size and a virtual image. So hopefully you were able to understand how the images are formed in concave and convex lens. I'll see you with another video where we're going to talk about a couple of math problems on this concept. Till then, goodbye.